In a previous video, I explained why you cannot trust forwarded emails. You have no way of knowing that an email forwarded to you is authentic, and this leads to scams, lies, and impersonations, and it means that forwarded emails cannot be trusted in a whistleblower case or as a proof for journalists or the justice system. And you may think that you can just forward an email that you have received in order to prove that you've received that email, but no, a forwarded email is not proof. You would need to give access to your email account or ask the email provider to attest to the authenticity of the email for you. And even if you have the entire email source, content, and headers, it is not enough, because the keys used by the email server or MTA to sign your email content, for example, to sign your DKIM signature, are rotated even daily. So your proof may be valid only one day. This leads to abusive measures in order to be able to prove digital content, even emails, like giving up your entire account or digital devices. And today, this is like giving up an intrinsic part of your identity. We need better protocols in order to have digital proofs without the need to give up more information than we want to. And now there is no way to prove a manually forwarded email through multiple accounts. So why would you need that? Think about institutions and citizen complaints. Right now, institutions are a black box and you have no idea how your case is processed. How about having the option to consent or not to your email being forwarded? There is no such option now. So I have a new email protocol for you. A provable email forwarding protocol. And this is a work in progress protocol, and I have achieved a prototype. This is what I will demo to you today. First, I have described this protocol in our WASM-X Provable Dev website, because this is part of the plugins that we offer for WASM-X, or Maximally Flexible Blockchain Engine. And here you can also see the existing email protocols described, like DKIM, ARC, DMARC, SPF. And this is the Provable Forwarding Protocol, which is heavily influenced by ARC headers. But ARC headers are created for automatic forwarding, and that happens when you tell your email provider to forward emails from one of your accounts to another one of your accounts. Now, provable forwarding works by not modifying the content of the email at all, so the body hash remains the same across all forwards, across all headers and all signatures in the forwarding chain. But we allow the user to change the subject, the date of the email, message ID from to CC, BCC fields, and others. But we cache these original headers that are changed in the provable forward DKIM context header. And this is also where we cache the original DKIM signature. And this is what helps us reproduce the original email and authenticate it. Now we also have a provable authentication results header. And much like ARC, this authenticates the servers that have sent the email that is forwarded, so we can be sure this is not a spoofed email from a fake server. The cached DKIM context. Now, provable forward signature header. This has a similar purpose as the ARC signature header, but it only needs to sign our provable forward DKIM context header. because this is the header that actually contains the original cached headers. But it also has two very important components, the DNS registry and email registry. The DNS registry is how we ensure that emails are verifiable at any point in time, and we do not need third-party email servers to vouch for our email authenticity. And this ensures that even private email servers are covered and their emails are provable, because the DNS registry caches historical public keys that have been used to sign DKIM, signatures, ARC, and others. The email registry allows users to express consent, and our specifications for these registries are not public yet. Now, the Provable forward seal header is similar to the ARC seal. It signs all the above headers for the current forward instance and also all previous Provable forward seal headers from previous instances, if this is an email that has been repeatedly forwarded. And now you can ask, then why not just use ARC? Well, because we want to allow users to modify the subject, date, from, to, CC and BCC headers, and ARC is not made for this purpose. Also, ARC alone would stop working after the server's signing keys are rotated, so we needed to create a different protocol. Now, for my demo, I will use our WASM-X platform, which also offers email server plugins for IMAP and SMTP clients and servers. So what I've done is I've set up the email server as a WASM smart contract on a blockchain. And by the way, this means you can have your own private blockchain for very important parts of your email communication that you want to be provable in time. And this gives you a lot of power as a citizen when communicating with institutions. Now, I have set up a machine here with everything that an email server needs, and I have a test here made to demonstrate forwarding. And let's look at the test. First, it creates some accounts on the email server, and then it sends an email from the test account to test2, subject and body, and then test2 will forward that email to test3 and will add something in the subject, and then test3 will forward the email from test2 to a Gmail account and also add something in the subject. And then to compare, we will forward from test3 to test, but we are modifying the body here so we can see if the forwarding checks fail or not. And then just send from test3 to test. So let's look at what is happening here. The IMAP and SMTP clients and servers have been started. Accounts have been created. Already emails are being sent and forwarded. So we should see in the Gmail account, we should see the doubly forwarded email, and also our fake forward has been sent. So we will look now into our Gmail and we can see the forwarded email here. And if we look at the original source, we see that all the checks that Gmail makes have passed: SPF, DKIM, DMARC, and let's see, we have some failures that are not important because DKIM passes for one key that we have for the server, but let's look at the provable headers. So we see we have two instances. We are at I equals 2, and we also have I equals 1 because we have a double forward. Now, the body, which is actually just this, has remained the same. And if we look at the body hash, this is the same across DKIM signatures, provable headers, and the ARC headers that Gmail has added. Now, this is for the first forward that has been done from test 2 to test 3. And this was added on behalf of test 2, and it should contain the original headers. So the original headers are from the test account with the original message ID, with the original subject, which is URI encoded, date, and the original DKIM signature that is base 64 encoded. And then these are the authentication results that were this header was created when test 2 has forwarded the email to test 3. And then this is the forward signature, the forward seal, and this provable forward check with a pass. This has been added by the email server on behalf of test 3 when it has received the forwarded email. So it has received the forwarded email and it made a check to see if all of these signatures were verified correctly. And then instance 2 was added by the email server on behalf of test 3 when it forwarded the email again to the Gmail account. And again, we have the context, but this time it is the context from test 2. So it is a forwarding chain, and the authentication results and so on to the forward seal with instance equal 2. Now let's look at the email that had a different email body, a modified email body. And that email has been sent by test 3 to our test account. So it should appear here, and we see the subject and the modified body. And let's see the mail source. So we see that the provable forward check that the mail server has added to the email on behalf of the test account when it received a forwarded email is fail, because the body was not conform to the body hash that was signed. Our provable forward signature at instance 1 did not validate, and that was the first error that was returned. So we know that this is not an authentic email that we have received, and we cannot trust anything from it because the signatures do not reflect the email content. Now, these provable forward signatures do not need to be implemented necessarily by the email server. They can be implemented at the email client level. So you can have even keys that a user controls which sign this information. We need better protocols in order to have digital proofs without the need to give up more information than we want to.